Yes, thank you. My name is Laurenz Edelmann, and I am a master's student from Eindhoven University of Technology who is studying physics. You might be wondering what a master's student is doing here at this conference. Well, I'm here to tell you about Team Polar, which is a student team that is developing a sustainable and autonomous research vehicle for the benefit of Antarctica. And before I begin, I'd like to thank the Netherlands Polar Program which we are here on behalf of, as well as for generously funding our trip here. So to start a little bit about our team, as I mentioned, we are based in the Netherlands, in Eindhoven, at the Eindhoven University of Technology, and we have a team of 25 different members from a very diverse background. So we have 10 different majors represented. As I mentioned, I'm from physics, but we also have mathematics, computer science, electrical and mechanical engineers, and it's a really diverse team. We're also more than 50% international, and we have people from 11 different nationalities, and that really helps to approach the problem from many different sides. So I might hear you ask, what actually is a student team? I can imagine this is quite a foreign concept to people outside the Netherlands. Well, of course, we're strongly affiliated with the university, and we are registered as a non-profit company in the Dutch Chamber of Commerce. So what this means is that we rely on sponsorships and subsidies and funding from, for example, the university in order to, break even, let's say. We have a continually changing team composition, which is to say that the membership in the team is changing every year. Some people stay year by year, some people leave, but the alumni pool that we have, the people who have been in the team, is constantly growing every year. And this really helps us to retain the knowledge that we gain throughout the years. The university has 25 student teams like ourselves, which you can see a picture of here. Some of those teams, a lot of them are also automotive, like us, and there's 700 students in them, which is about 5% of the student body, so it's quite an exclusive program. And as I mentioned, financially we are funded via company sponsorships and partnerships, which I'll tell you a bit more about later, as well as funding from the university directly, which is shared among all student teams, and also European and national subsidies, which we have not yet applied for, but we hope to do in the near future. I should also mention Innovation Space, which is the home of student teams like ourselves and gives us the technical resources to be able to do projects like ourselves. Yeah. So they have mechanical workshops and technical expertise there as well. What are we doing? I mentioned we are building a sustainable and autonomous research vehicle. So what does that actually mean? Well, it's sustainable in the sense that we have an electrified vehicle, so it is powered via solar panels, and there's an electric drivetrain which avoids the usage of fuel, as you can imagine. It's also autonomous, so it is self-navigating by using various different sensors, which increases the human safety factor and reduces the effort required to collect research. At least that's the idea. It's also affordable, partly because of these previous two things that I mentioned, but also because of the cost-effective development. What I should mention is that we're students, so we do this voluntarily. We don't get paid for this. And the cost burden comes from the subsidies, the university, and the companies that we develop our vehicle in partnership with. So this decreases the cost burden of the logistics and collecting data. Some potential activities that we have thoroughly researched for our vehicle and that we think it would be suitable for are environmental mapping. And this includes, for example, the planning of safe routes for logistics, but also things like ground-penetrating radar measurements and characterizing the snow and ground properties. Meteorological measurements, and by this I mean the frequency of precipitation phenomena like snow and wind and things like this. And of course the classical meteorological variables like temperature and wind speed and so on. The final one is a bit more exotic, which is meteorite detection, where we hope to investigate, for example, the number and location of meteorites at certain locations in Antarctica and classify their type. I mentioned that we're sponsored by partners. Here's a slide to demonstrate that. So many of these are based in the Eindhoven kind of ecosystem, but many of them are also internationally known. And we not only receive funding from these companies, but also in-kind parts and expertise, which helps us develop our project quite a lot. We're not alone in this, so we're not just students doing this project, but we have quite a sophisticated advisory network that we've developed over the last 4 years, which of course involves Dr. Dick van der Kroef and Dr. Daan Blok, the former and now enacting director of the Netherlands Polar Program. That's sort of on the Antarctic side, and that's also the big reason why we're here today. Then we also have sort of a technical background by Dr. Dr. Chris Verhoeven, the theme leader of swarm robotics at Delft. That's an expertise region there. And also the technical staff at Innovation Space. On sort of the Antarctic terrain regime, we have Johan Berthe, who's the CEO of Antarctic, which I'm sure is a company many of you are familiar with, and also Laurenz, who is an expedition leader, because of course we have never been to Antarctica, so we cannot imagine the terrain, and we want to know what this terrain is like when we're developing a vehicle for it, of course. And finally, we have, for the application side, a lecturer in meteoritics at TU Delft, for the meteorite application I mentioned earlier, as well as a PhD student who is focusing on using GPR research and to validate satellite data. So what did we do in the past 4 years besides setting up a foundation and generating this team? Well, we spent 2 years, which were also heavily COVID-ridden, as you can imagine, developing our first concept vehicle and designing it, which we then built last year in just a year. And we had the pleasure of testing in Norway in the vicinity of Trondheim earlier this year in January. And we were quite satisfied with the result, and this kind of taught us the development cycle of developing such a vehicle over 4 years, what went well, what things can be improved, because yeah, as a team we had never done this before, and this knowledge is now, well, almost finished being reviewed. I should mention this vehicle is not ready for Antarctica, so I can imagine you would be quick to point that out. It's built right now for about minus 20 degrees Celsius, and it's been tested until minus 10. That's the coldest we reached in Norway. What does the future look like for us? Well, this is a sort of preliminary action plan that we have for the next 4 or 5 years. As I mentioned, we're still wrapping up the review of the current design process, and we will begin designing a second vehicle which will meet the requirements of Antarctica in September of this year. We hope to make some small modifications and perhaps add some research equipment to our first prototype, which I just showed you in February, and test it in an Arctic location, which is even more exotic than Norway. In about 2 years' time, 2.5 years' time, we hope to complete the second prototype, which should be ready for Antarctica, and begin testing that locally in climate chambers and such. And then actually start testing that also in the Arctic, most likely in the same location we tested the first prototype in. Then September 2026, we hope to arrange for the second prototype to go to Antarctica, adding research equipment to it, rigorously testing it, arranging the permits, and all of this type of thing, and then finally get it working around a base in Antarctica around 2028 in that Antarctic season. So you might be wondering, why am I telling you all this? Well, we are here because we want to collaborate with you. We are students who really enjoy the engineering aspect of developing such a vehicle for such a difficult environment, but we are not researchers. And we want to make sure that our vehicle is useful to you. So we're here to look essentially for a partner who wants to co-develop this vehicle with us, who thinks that this might be interesting. What you can expect from us are our regular development updates and close collaboration with you, and a fast line of communication with us because we're students, so we don't take breaks. We, of course, want to build a custom machine for you that meets your design requirements, so you have the benefit of collaborating with us right at the beginning of the process, so you can really shape the vehicle to what your needs are and to what the local environment is. And of course, a passionate and competent team which is constantly evolving and constantly learning. We have some expectations as well from a collaboration. Of course, in order to develop a vehicle from an engineering standpoint, we need to know the environmental constraints for the operating region, what temperatures are we designing for, what terrain and such. Of course, we also want some assistance in locating a research group for the end application. So as I understand it, most of the people here are logistics managers and not necessarily people doing the research themselves. Maybe I'm wrong about that. But of course, we would like to have research equipment on board the vehicle because that's, in the end, what we want to design it for. We also want to interface monthly with the end users to make sure that we can design the vehicle for their benefit and to make it as easy as possible to use. And ideally, we would like your help facilitating testing and applying jointly with us for funding. And all of this can be kind of wrapped up in a sort of letter of intent for both sides to reach this agreement. But of course, all of these points are suggestions and subject to much more detailed discussion. So with that, I'd like to thank you for listening to me and also welcome you to please approach us in the coffee breaks. We'll be here until Friday. You can identify myself and my colleague Jord with our nice t-shirts. And we are also available at this Australian phone number for the next 2 weeks. After that, you can always contact us via email at info@polar.org. So thank you very much, and yeah, enjoy.
Thank you, Laurenz, for sharing this presentation, and the call for collaboration is open. And also questions for him. Please.
Hi.
Hi.
Very interesting. I just have a quick question whether underwater has been thought of, or is this purely land-based?
Our expertise at the moment is on land-based vehicles. We have heard that there's interest in making an underwater vehicle. Right now, that's not really our focus area. But in principle, we are open to collaboration of any sort, so we're still happy to have a discussion.
Okay, because my experience was I was involved with the finding of the endurance using the underwater and semi-autonomous as well. So something we can talk about.
Okay, we'll definitely talk to you. Thanks.
Thank you very much for the presentation and congratulations. And he asked the questions about the technology part. I am asking questions about the students club parts actually. Are you looking for having a collaboration between other students clubs around the world, or?
Of course, always. Yeah, we love visiting other universities and sharing knowledge with other student teams. But yeah, at the moment we are really here to really get a formal collaboration with a research institute, for example, and a station. But for student things, we're always open as well. Yeah.
All right, then. I don't want to take too much time to everybody. We can discuss it.
We'll discuss it for sure.
Thank you very much for the presentation again.
Thank you.